All right, lecture 9, just a continuation of lecture 8. We're going to keep going with the demos. This is how far we got before we were left off with the flying number. So we're going to do that, and then we're going to do these other things here, like our pie will be animated and our dealing the cards off a deck. Let's head back to our Xcode. All right, here's that flying number overlay that we had. And I'm going to review the last 30 seconds of the last one just to orient yourselves as to where we were. We added this flying number as an overlay because when we have a match, it's going to do +2. It's going to appear here, and then a +2 is going to come floating up, or a -1 if we have a mismatch, and it's going to go floating down. So, of course, we need an overlay of that flying number. And the flying number, what the actual number that's going to fly, is whatever that last card that we clicked, whatever score change it caused. So if it was a match, it would cause a score change of +2. And so we're going to fly up. And if it was a mismatch, -1. And if there's no change, then it's going to be 0. This score change function down here, we're going to have to implement to keep track of what the score change was of the last card that we chose. And then let's go peek over at flying number. This was a very simple little view. Its body just has the number that's supposed to fly, and it shows it as text. And we learned this new thing with text that we don't have to always pass a string to text. Sometimes we can pass a number, but when we do, we have to use a formatter that knows how to format that. And this works for other things too, dates, right? You can pass a date and then have a date formatter there. And also notice that we don't show any number here. We don't even put a text up there if the number is 0, because we don't want 0 flying up and down as we click here, just +2 and -1. Let's hop back to our view and implement this score changed thing. So to do that score change, we have to keep track of what the score change was of the last card we had, which means we have to simultaneously keep track of what the change was the last time we clicked and which card caused it. And whenever we have two things like that we want to keep track of together, one of the data structures we can use in Swift that we haven't shown yet in demo, but you hopefully read about, is a tuple. Let's create a tuple, and in that tuple, we're going to keep track of which card was the last one chosen and the score change that went along with it. And it's going to be state, so let's do a little @ state, private var. I'm going to call it last score change, because that's what it is. And what is its type? It's type tuple. Here's what it looks like to define a tuple. I'm going to put the amount as one of the things in the tuple, and then I'm going to say the caused by card ID to be, you would think, a string, right? Because our cards, their IDs are string. And I want to keep track of the last card that caused the score change by its ID, but I'm not going to use string right there. Instead, I'm going to use this type, card.id. Now, why am I using card.id, and what is card.id? This is the don't care from the identifiable protocol. If we go back and look in our model at card implements identifiable. It conforms to the identifiable protocol, and we know that because it's got its little ID down here, string. If we go look at the identifiable protocol in the documentation here, we'll see, here's identifiable, that it has this associated type. And we know that that's a don't care. And so this is a type. This associated type, it's a type. It's a don't care, but it's still a type. And we can use that type on card back here as a type for something else. And this is, as I'm sure you can all agree, much more clear about what I mean by this caused by card ID. I want it to be the ID of a card, right? So yes, that's the same as string, because we know that the don't care of a card when it implements identifiable is a string. We know that, but here we don't have to know that. We can just know that this is the identifiable for the card. So let's go back to understanding the tuple. A tuple can have any number of pieces of data in parentheses. We only have 2, but we could have more. We could have another one, X is of type double. That's perfectly allowed. We can have as many of these things as we want in our tuple type. And then we can assign it by, of course, just saying equals. Let's start it with an amount being 0 and the caused by card ID being empty string. We know that's not a valid card ID. One thing when we're using tuples, we use Swift type inference a lot. For example, I would not put this right here. Even though if I option click on this, you can see its type is a tuple, right? Where the first thing's an int called amount, and the second one is a card ID called caused by card ID. If I take this away, this thing right here, it's still going to think that that's its type because it's going to infer it from the initial value I gave it. Now, another thing about tuples to understand is that you don't absolutely have to have these names. In this case, I probably don't want the amount. Look at the name of this var, last score change. This is the last score change. Do I really need to say last score change amount was 0? No, the last score change was 0. And also we want to know what card caused it. So this is kind of how you define a tuple and use it. And we're going to show you down here in score change how we access the value of a tuple. But first, let's set this var. How do we keep track of the last score change? Well, when does the score change? When we choose a card. Let's update this var every time we choose a card. Real easy to do. You create a little local here called score before choosing, and that equals our view model's score. And then right after, I'm going to say let score change equal the view model's score minus the score before choosing. Does everyone agree that that's going to keep track of score changes? Because every time I choose something in my model, the score might change. Maybe there's no change, it's 0, but it could change, and this is a way to detect it. Now that I have the score change and I know which card is involved here, right? I'm inside my aspect V grid. I'm obviously drawing the card with the card view card up there. I know which card it is. Now I can say that my last score change equals the score change and caused by card ID, the card's ID. So this is how we assign the value of a tuple. We just give the two things in the tuple. By the way, when you're assigning a tuple, you don't have to put this in here. You could do that. That would be perfectly legal. I probably wouldn't here. I think it's a little clearer to go like this. Someone reading my code can see this line in code and say, yeah, oh yeah, the last score change was this score change and it was caused by this card ID. Now we know what our last score change is at all times. Let's go down here to this func at the bottom and implement that by just looking at the last score change. We're asking about the score change that was caused by a certain card. The only card that can cause a score change is the last card that caused the score change. Any previous ones we don't really care about, right? We have these flying numbers. We don't want them flying from previous cards. So whenever something changes, we want something to fly. So we really only care about the most recent one. How do I get the values out of my tuple? I have my tuple here. How do I get it out? I can say let amount, comma, caused by card ID equal the last score change. So when you're getting the values out of a tuple, you say let, and then a variable name. This can be any variable name you want. I called it amount. It could be foo, well, we're concerned. And then caused by card ID, this also is a variable. When it pulls it out of here, it's going to put the two values into these two variables. So I'm essentially saying let amount equal the first thing in the tuple and let ID equal the second thing in the tuple. And again, here, I don't need this name if I don't want. Take that out of there. That's also perfectly legal. And what is the score change that's caused by this card? Well, if this card's ID equals the ID of the last score change, then it's that amount. Otherwise, no change. I'm going to show you another way to access tuple stuff, but that I don't recommend that much, but you'll see it, so you got to know, which is I could say return last score change dot 1 equals cards ID question mark last score change dot 0 colon 0. Now, the reason I don't recommend this is pretty obscure to understand what's going on here, but dot 1 on a tuple means the second thing in the tuple. Dot 0 on a tuple means the first thing in the tuple. I don't really recommend doing this. There are probably a few times when doing that syntax would be good, but I don't generally recommend it. When I flip these over, they should start showing this number, right? Let's take a look. Let's try here. That obviously didn't cause a score change, so no number there. Another one. Oh, that did cause a score change, right? +2. You can all easily see this 2 right there. Yeah? No, obviously very difficult to see because it's orange, so you can barely see it, and it's small. I'm going to zoom in so we can see it a little better. Now can you see it? That 2 right there. But this is terrible. Even with this, if this flew up, we'd be able to see it better, but it's still not what we want. So let's go back to flying number and make this 2 a lot more visible, look better. Back to flying number here. And what can we do to make this better? Well, one thing we could obviously do, let's make it large font. So we'll make this largest font we know of here, which is large title. That'll help. What else can we do here? The color, we don't want it to be orange. It's going to fade into the background of everything there. So let's make the foreground color. Since we're changing the foreground color, let's have it mean something. How about if the number is less than 0, then let's have it be red. Otherwise, we'll have it be green. Positive numbers, positive score will be green. Negative will be red. That'll be nice for the user. But there's lots of other things we can do to make it more visible. We can put a shadow on it. There's a view modifier called shadow. We put whatever color we want here. How about black? And you specify the radius of the shadow, how far it goes out, say 1.5 points, and how much it's offset by x1, y1. It's going to be over to the right and down 1, because remember, positive y is down in iOS. And the only other thing is, remember it said 2. Really would like it to say +2. You know, when my score comes in, I like +2 instead of just 2. I can do that with my number formatter up here. Remember this dot number formatter? Well, there's something on there which is called the sign strategy. That's the strategy for what sign is. And I'm going to say always show the sign. I put that one up there mostly to let you get an idea that there's an awful lot of stuff inside of SwiftUI that I'm not showing you the details of. You got to start looking in the documentation for things. If you have a number and you want to format it, you know now that there's a number formatter. You're going to go look that up in the documentation, see what formatting options are in there, and pick the ones that you want. In our case, we want the number sign strategy to always show the number sign, even when it's a positive number. This will probably look a lot better. Let's go back here and try it again. This one, woo, that's way better. Much. You see the little shadow there, nice bright green, got the plus in there, very, very visible here. All right, now we need to make it fly. We want our +2 to fly up when this matches. How are we going to make it fly? Well, let's start by talking about how we can make this thing be not in the middle. Notice we put this flying number overlaid, and of course it put it right in the middle. Where else would it put it? Well, if we want to have it move up a little, we do that with another view modifier called offset, .offset. So .offset is an interesting view modifier. It offsets a view from where it would normally be placed. So if it was in an H stack or a V stack, right, it's going to get placed in this right place, and then .offset offsets it from there. So .offset is like relative offset to where it should be. It's different than the view modifier .position. That's the absolute position inside your container that it's in. And we'll see that as well a little later in the quarter. But .offset is nice. It's this relative offset. And that's exactly what we want here, because we want it to appear here in the middle and then relative to that move up or down. So let's put a .offset on our text. .offset. And it's X and Y, so we don't want it to be any offset in X. We don't want the number to move left or right, but in Y we do, and I'm going to have it be a state. So @ state private var my offset to CG float. We'll start it at 0. So offset of 0 means it's in the middle. If we go here, get this number back up, you can see offset is 0. Let's change it to be -50. Okay, minus 50, right? It wasn't in 0, it was 50 points up. So we're pretty sure that this offset works. Again, minus means up in iOS because our coordinate system is upside down. But we don't just want it to appear up here, we want it to fly up there. We want it to animate. And when do we want this animation to start? We want it to start as soon as it appears. As soon as this +2 appears here, we want to immediately have it start animating up. And as we learn in the slides, we can do this on appear view modifier, and that just has arbitrary code in there that we can do when this thing appears. What's kind of cool is this says number not equal 0, so this text is going to appear when the number is not 0, like +2 or -1. That's going to make this thing appear. And what are we going to do in appear? Well, I'm just going to say with animation offset equals, if the number is less than 0, then I'm going to go to 200. Otherwise, I'll go to -200. Let's see if that works. Whoop, worked. Really nice. And except for we don't want it to start at -50. We want it to start at 0 and go up. Very nice. So that was quite easy. But we don't want it to fly up there and then just get stuck and sit there until we click the next card. Right? If I click another card, then it's going to go away because the card went away. And here we go again. That actually went up off the top of the screen there. We don't want it to stay. We want it to like fade out or something, disappear. How do we do fading? Opacity. We want, obviously, an opacity thing here. And what is the opacity that we want? Well, when the thing first appears and it's at offset 0, we want it to be fully opaque at 1. But when it gets up here, we want it to be 0. So really the opacity is hooked to the offset. So we want to say if the offset does not equal 0, then we want it to disappear. Otherwise, we want it to be there. And this sounds like, oh, wait, this is not going to work. But remember that this is inside of with animation. So this opacity, it's going to change from when it first appears at offset 0 up to here. And that change is going to be animated. So that's why it's going to fade out. Let's see this in action. Worked great. A little fast for my liking. Kind of zoomed by so fast, I didn't really get to appreciate the +2 that I got there. So let's slow our animation down. We know how to do that. How about something like ease in? I don't necessarily want it to ease out. I want it to ease in, but not ease out. And duration, let's try 1.5 to start, see what that looks like. Maybe that's a little slow, but it's not too bad. Probably live with it for now. And we can tweak these numbers over time. This wants to be a constant for sure in this flying number. And we're not going to do the constants here. All these want to be constants. These things, even these up here, want to be constants. So we would create a struct with statics in it like we always would for constants. Now this looks like it's working, but it's actually got some problems. And I really don't see them unless we back up a little bit. So let's back up actually to see all of our cards here. Watch this problem. So here I have my demon, and here's this. No score change there because neither of those cards have been seen, so they're not negative. But now I'm going to make it so that they're not seen. Ready? Watch this. Okay, -1. Flew down. Now I'm going to match the pumpkin, and I should get +2, right? +2 should fly up from the pumpkin. Here we go. Watch this. Oh, no +2. Well, the problem here is it's only going to show its flying number once. Why is that? Well, the text appears, sets the offset to be 200 or -200, then the offset just stays there. It never gets reset back to 0. So it never appears again because there's never any animation that's going from. When this happens the next time, you set the offset and it's nothing, the offset is not changed. So we need to, on disappear, when we disappear, we need to set the offset back to 0. And we don't have to animate it or anything because it already will have faded out. So we're not going to see it anyway, even if we animate it. So we'll just reset our offset to 0. Now watch if I do this. This guy, we'll have him do a -1. Now we're going to have this guy match. +2. It works. So we sometimes have to be careful when we on up here and we set some @ state, we might need to reset it when this thing disappears. Now there's actually another problem. Watch this problem. Let's go here. We've seen this guy once, and now we're going to see this guy again. He's going to do -1. When I tap on this guy, he's going to do -1. Ready? And watch the -1 very carefully. Ooh, it went behind this card. Did you see that? The -1 came out, but then it went behind this other card. That's not good. Let's see that happen again. With this guy over here. Now watch the -1 behind. It went behind that card. Why is that -1 going behind another card? These cards are all at the same level in the UI from a Z stack, right? From stack. Now, they're at the same level in terms of their priority to be there, but they're kind of laid out by the for each and the aspect V grid and the lazy V grid. In some way, we don't necessarily know for sure which ones are in front of which other ones. It turns out it looks like the ones at the beginning are in the back and the ones toward the end are in the front, which kind of makes sense, but we don't know that for sure. But we need to be sure. When we click on a card and it causes a score change, we need it to be in the front. No matter which card it is, it has to be in the front so that when this number flies up, it flies out on top of all the other cards. So how do we control the Z-ness? We do that with something called Z-index. So I'm going to go back to my memory game here, and the same place where I do my overlay, I'm going to say that the Z-index of this card view, if the score change for this card caused by this card does not equal 0, then I'm going to have its Z-index be 1, otherwise 0. Now Z-index can be any floating point number, and 0 is the default. Higher numbers are in front. And I can use that Z-index, other numbers. If I want to order a bunch of views in a certain order, I can pick different numbers. It doesn't have to be 1 and 0. You could definitely set this to 100 and it would work just as well. So now let's make sure that worked. Let's go here, click this guy. Okay, let's have this guy be wrong. -1, it's on top because that card was the last card that had score change, so its Z-index was 100 in this case in front. I'm going to do a little code cleanup before we go here. I'm getting a little worried about this function. It's getting a lot of lines of code. It's getting towards near my limit of a dozen lines of code. There's an obvious thing to pull out, which is this. I'm going to pop this out of here and create a function called chooseCard, which is a function on this. And all that chooseCard is going to do is the same thing that was in there before. So again, I'm just breaking it up into smaller pieces. The next thing I want to do is this pie. You see our little pie behind the spider? That's supposed to be a countdown timer. Okay, I have it set to be in my code here that you're going to see 6-second countdown timer. And I'm going to give you 1 extra bonus point for every second you have left. So if you match them really quickly, you get a lot of extra bonus points. But if you take a long time, then that little pie ticks down, you lose all your bonus points. So 1 point per second you have left. But clearly, this needs to animate to show that happening. Now, that bonus scoring is part of my model. So all the logic for what the time is and how many points you get, that's all in my model. So let's go over to my model and put it in there. And it's in my card, something about a card because it keeps track of how long the card has been face up, and the longer it's been face up, the less points you get. And I'm not going to show all this code and type it all in. I have a little code snippet for it. You can go look at this code afterwards. I'll post it on the forums there. But here's basically how it works. It's in this section I just put in here called bonus time. And you just call this function start using bonus time every time the card goes face up, and then stop using bonus time every time it goes down. And that's just causing the card to keep track of how long this thing is face up. And then once you do that, you get this nice little var here, bonus. That's how many bonus points you get if this card is matched. And you can see that it is just the time limit, 6 seconds, times the percentage you have remaining. So if you have 50% of the time remaining, you get 3 points. And then there's this bonus point remaining. it's just doing a little calculation right here to say, well, how much time have you used? How long has the card been faced up? Divided by how much time you get. Right? You get 6 seconds to get a bonus. If you don't match the card within 6 seconds, you get 0. So now we're going to use this code in our model. First thing we're going to do is when is face up happens, we're already doing something on is face up, which is keeping track of the has been seen when we turn face down. But now I'm also going to say if is face up goes true, then I'm going to start using the bonus time. Else, if it goes face down, I'm going to stop using the bonus time. Here we're using property observer again, really good use of that. And same thing with matched. When we're matched, we want to stop using the bonus time there too. That's it. So I've got my model now. It's keeping track of how much bonus you get here. Let's go up to our scoring and add this scoring to it. So here's where we have a match, scores +2. In addition to the 2 points, you now get the card's chosen index dot bonus. And also the card's that potential match index, which was a match, dot bonus. There we go. That's all I have to do in my model to keep track of this. If you match the cards quickly, you're going to get a lot of points, and you're going to see this because our flying number, it's not going to just be +2. It's going to start saying +7, +10 if you match them really, maybe +12 if you just really quick match them right up. So we'll see that happening. Let's go back to our memory game right here. How can we see it? How do we visualize what's happening in our model? Well, we have the pi in our card view. Instead of 240, we want it to be our card's bonus percent remaining times 360. There it is. It's 100%. It's not moving though. We haven't put any animation in, so it's not moving, but it is happening because watch this. Let's go over here, go here, and go back. Look, when the card flipped straight up, it showed that it had seen that card a little bit. Same thing here, back. Oh, very little left. Here, here. If I go quickly, see how these cards are actually showing how much is being used? It's just that it's not ticking in real time. It's not animating it in real time. Now, there's a couple of ways we could do this animation. By far the simplest way is to use something called a timeline view. So a timeline view is a really simple view that just takes whatever view builder you give it, and it does that animation thing where it slices it up into pieces and calls you repeatedly. That's exactly what we're going to do. We're going to take our entire pie and just put it inside a timeline view. A timeline view takes an argument for how often you want to do it. Like we could do it every minute. That would be useless in our case because our thing only takes 6 seconds. But it has a great one called animation. And the animation one syncs up how often it calls this with the animation passes that it's making. So when it's doing animation, we know that it slices it up into pieces. Well, that same kind of piece slicing rate, whatever that is, that's what the animation timeline does. We just put our pie inside there, and look at that, timelining it down. The bonus time percentage is changing in the card because the card is keeping track of how long it's been up, and the timeline view is redrawing it repeatedly. And you can control how fast it redraws too. You can say minimum interval, for example, let's say 1/5 of a second. Now when we click, see how it's kind of chunking? Every 1/5 of a second it's doing it, which is nice. That's going to use less of your battery, essentially in your phone. We haven't really talked about performance and all that. Really using a lot of CPU, forget that. You're using the user's battery. The more you crank that CPU up and start drawing a lot of things, you're using their battery faster and faster. You might decide that it really is not that much more valuable for them to get a smooth turn here versus a chunked one. Or maybe you make a compromise and say, well, I'm going to let it chunk, but it's going to be at this rate. But you might decide that's distracting and you want it to be smooth. So make it smooth if you need it, but you do have control of how much you can do it. So we'll go ahead and let the animation system pick the rate for us there. Notice also the timeline view gives you an argument. You see that timeline? let's take a look at that in the documentation here. This is the default one. We'll go look at what a timeline context is. And one of the most important things in that timeline thing that it gives you is the date. That's the current date of that the slice happened, that it drew that for. And so you can look at that date. Now, we don't need to look at that date because our model is really smart. It knows how much time has been consumed. It can tell you that at all times. But you might have something where you want to, based on how many seconds since the last time you drew it or whatever. You don't usually need that cadence and stuff very much. A lot of times you're just doing this animation thing and putting your view in there. You wouldn't want this to be really expensive to redraw, which ours isn't. That pie, drawing a shape is like very little CPU usage, but you wouldn't want to build some gigantic, if you're doing you have a research project and you're doing some gigantic data processing, you wouldn't want to do that in a tight loop inside a timeline view. You want that data to be quickly available to it. While we're here, let's go ahead and clean up some more, because look at this one. More than 12 lines? I think so, right? Maybe 13, 14, I can't really tell, but not good in any case. This whole thing definitely wants to be its own. That many view modifiers on something, so I'm going to take that out of there. Create a little var here. I'll call it the card's contents. Some view. Put that back in here, and then the overlay is the card contents. Rid of that. One thing I'm going to pull out here is this padding of the pie inset. That's not really part of the card's contents. That's more up here as part of the layout of that whole thing. So I'm going to put it up there really where it semantically belongs. Someone also asked me, hey, does overlay have to just be a single view like this? And the answer is no. Overlay could be a normal view builder like this. All the overlays we've done just happen to accidentally, I guess, be these single views. A lot of times they might be single views because you're doing what we're doing here and pulling the view out into its own var like this. Remember this thing, dot transition, that I talked about, which is the coming and going of views when they come and go, and animating that. Let's try and do something here that helps us see that visually. And what I'm going to do is the disappearing of the cards when they match. When we click on cards that match, like these two guys, when I click on the next card, they simultaneously flip and fade, which is actually kind of weird because the fading of the flip kind of breaks the illusion of the flip. So we don't really want that. And I'm going to do that disappearing of the card. Instead of using opacity here to make the cards go away, I'm going to actually make it go away. I'm going to make this card actually disappear. I'm going to take this same if that we had right here, I'm going to cut that out of here, get rid of the opacity, no more opacity. Instead, up here, I'm going to say if that thing, then draw the pie. All right, this pie is the cardified pie. You see there's cardified at the bottom, so this is the whole card. I'm just not going to draw it. So that pie, cardified pie, is going to disappear from the UI when it's matched and face down. So here we have a case of a view, the cardified pie, leaving the UI. Now when I do it this way, look what happens. Right? I'm going to do a match. I'm going to click, and we're going to make it disappear. Watch what happens. It still fades out. Now it is better because it didn't do the card flip, but it still fades out. Let's try this one. Ready? Fade. Uh-oh. And even worse, it removed the whole view, and now our thing collapsed back up, which is why we did the opacity in the first place. If you remember way back, just lecture 2, we made that be opacity so that it would keep the space when it wasn't there. So in some ways, we've made things better here. In some ways, we've made things worse. And in some ways, we haven't changed anything, right? We haven't changed anything because the opacity is still happening somehow, even though we took opacity away. We made it worse because it collapses like this. But we've made it a little better in that it's not doing that card flip anymore. It's just making the cards disappear. So let's try and understand why all these things are happening here. First, let's talk about the fact that it's consuming the space. Well, when you take that view out of there, our little aspect V grid says, oh, okay, well, minimum width be damned. This thing has nothing to draw. It's an empty view. There's no view there. That's a simple one to fix in another way besides using the opacity trick, was just to say color.clear. So color.clear is like saying rectangle.foreground color clear. Clear is clear. And that is going to make a rectangle that's going to sit in that space that you can't see. So watch this. And this, and when I match, whoop, disappears. And now there's a clear rectangle here. You can't see it, it's clear, but it fills that space. So that's a simple way to stop that collapse. Views are still coming and going here. The cardified pie is still disappearing. Now, what about the opacity? Why is it, when I click here, fading out still? How could it possibly be fading out? There's no opacity for the cardified pie. I've got the opacity, for my little countdown timer, but that's a different opacity. I deleted that opacity. Well, that opacity is coming from this. Dot transition dot opacity. Opacity is the default transition to use when you remove or add a view to the view hierarchy. And since it's the default, it's just like you have that on there. And if I click again, click, match, whoop, opacity. It faded out. What if I change this? How about scale? Remember, scale is a different kind of transition. That's a transition that makes it go from big to small or small to big. Let's see what happens here. Whoop, do you see that? Zip down. So we just used a different transition there to make it disappear. And this transition mechanism is a really cool way when you have a view that you want to wholesale disappear or appear or fly away or something like that in your UI. Make sense? We're going to do more transition, but I just want to do a quick intro here that's really clear what's happening. All right, last thing I want to do here is dealing the cards out. And dealing the cards out involves a number of things going on all at once. And the first thing we got to think about a little bit is how do we want to kick off the dealing of the cards? And I'm going to start by having the dealing of the cards happen when the game appears. What if I wanted them to deal out, like a dealer deals cards in Vegas, right? I want that kind of animation. How would I do that? Well, the first thing I have to do is make these cards appear after its container is already on screen. Because if the card's container is not already on screen, you will not see any animation of them coming on screen because they'll come on screen with its container. And what is the card's container? It's our aspect V grid, which is got a lazy V grid. That's the container. So we have to make sure that thing be on screen first. Let's talk about how we make this work. First thing I'm going to do is I'm going to say when my aspect V grid of cards appears, then I'm going to deal the cards out. So I'm going to let my aspect V grid appear, and then once it appears, then I'll deal the cards. Because then I know it's on screen. The container is on screen. Dealing the cards is not part of my model. There's no part of the memorized game which is dealing cards. The game has just got the cards. So the dealing is purely a UI thing. It's the UI that wants to present this game by dealing the cards out to you. So we're going to need some @state to represent these cards and whether they're dealt or not. So I'm going to create a little private var and call it dealt. And it's going to be a set of these card IDs. Again, I'm using card ID there instead of string. And I'm always using the IDs of cards, of course, because the cards themselves are copies. This is a value type, so it's copies. Whereas the card ID is a unique identifier for the card. And this little set, if a card ID is in this set, then the card has been dealt. Otherwise, it has not. Notice I start it empty. That means none of my cards have been dealt. Now, once I have this nice little @state data structure, I could create little functions like, is this card dealt? I could return a bool. And this is just going to say dealt contains that card's ID. Or I could have another nice little var called undealt cards, which returns an array of cards. And that could just be my view models cards, but filtered so that I'm only showing the ones that have not been dealt. See how I can use my little private var dealt here to create some semantics about whether the cards are dealt or not? And it's important to understand that this is @sign state. I told you we don't really have @sign state in views. The only @sign state we have is temporary state, UI oriented state. Well, dealing the cards is a UI thing. It's not in your model. It's not part of the game. It's purely part of the UI. So this is a great and obvious use of @sign state. So now I can find out whether cards are dealt. What I'm going to do is go up here to my aspect V grid, and I'm only going to show a card if it's been dealt. I'm going to go here and say, if is dealt this card, then show my card. Notice that I'm using an if there, so when the card is not dealt, it's not on screen at all. This view is not even on screen at all. And when it gets dealt, if I ever put it inside of this set, then it will appear on screen. You can see no cards, right? No cards over here because none of my cards have been dealt. All right, so let's deal our cards out. Let's do it right here. It says deal the cards. I'm going to do it animated, so I'm going to say with animation. And let's do a little slow animation so you can see it. How about ease in, out, duration of maybe 2. And what do I need to do? Just for card in my view models cards, dealt.insert that card's ID. I'm just going to put them in my set. That's going to cause those cards to be dealt. And look, there they are. But we have a serious problem here now. We've reached a limit in a way of the previews. When you start doing animation like this, where things are happening on a pier and all that, you can't really use your preview. It will not show it. If, for example, if I restart my preview by clicking on the live button, look, it didn't do it. It just, they were already there, so it left them there. And it's a little bit about how the architecture of previews work. So this is a case where we have to use a simulator. We've gone this whole quarter, we never use a simulator. I know some of you have used it because you're not on the latest Xcode, but we've had no reason to do it. And now I'm going to show you what it looks like to use the simulator. And it's a couple of things we're going to do here. One is let's close the preview. We're not going to use that. I'm going to take this out of full screen mode. And here's my simulator over here. See? I'm going to do something really cool. So watch closely. I'm going to say window, tile this on the right side of the screen. And when you do that, it's going to, on the left, give you all your other windows that are up and say, which one do you want to be on the other side? And I'm going to want Xcode. And now I get this nice tiled view between these two apps. And this will stay on screen for me. Now if I run, woo, you see it dealt the cards. Okay, well now it dealt them with opacity because that's the default transition. This view came on screen and it had the default dot transition, dot opacity, and that's why when I run and my container appears, I get this fade in. So my cards were dealt by fading in. I could definitely control that. What if I make this one scale, just like I made the other one scale? How about that? Here come my cards, scaling in. Or I could do something even cooler. How about this transition? There's one called offset. Offset lets you pick an X and Y to offset, and it's like where the card will start from, and then it'll go to where it wants to be. So let's say X, how about cgfloat.random in -1000 up to 1000, and same thing for Y. Copy and paste even, pick a random position, random X and Y. Probably going to be off screen for most of them because 1000 is pretty far. Screen, by the way, is, you know, on an iPad, it's maybe 1200 by 700 or 1400 by 900. And then on an iPhone, it's maybe 400 wide by, I don't know, 800 high, something like that. You never know and you don't care because notice we don't ever have to know that. But 1000 is pretty far. Let's see what this looks like, this transition. Woo, there they are. They're coming from some random place and coming in. So I'm controlling with transition how this card view appears on screen. And it appears once it is dealt. And it's only happening here because if I didn't have this with animation, then it wouldn't do this. It's because of that explicit animation causing that transition to get animated. All right, so that's step one of understanding what's happening here. Those things are appearing on screen. Now that's not quite what we want. We want to have a deck of cards somewhere, and I'm going to make it so when we tap on the deck of cards, it deals them out. Let's work on getting a deck of cards on our screen, and then we'll try and sync them up so that they're transitioning together. The deck of cards, pretty easy to implement. Probably all imagine what this is. Let's say var, private var, deck, which is just some view. And a deck of cards is really just a Z-stack of cards. So I'm going to say Z-stack for each. And which cards are in our deck are undealt cards. See the undealt cards right above there that I created earlier? Card in. We're going to draw it with the same card view that we drew the other one. There is one thing I do want to do with this, though, is I want to explicitly give it a size. And this little view modifier that I'm going to show you today, dot frame, easily abused. Be very careful of using this one. What is frame about? I told you that views get to decide what size they want to be. Remember that? Well, they can do that with frame. But frame is not really going to size the thing itself. It's more like it creates a container that's that size, and the thing then is offered that space. Remember how in layout you get offered space, you size yourself to go in there. So frame will offer you space. Now, a card view uses all the space offered to it. So if I say frame, let's say width, my deck width, I'll make a constant for that, and the height then would of course be our deck width divided by our aspect ratio, right? That would be its height. If I said that, it would make a little container that size, and our cards would draw the whole thing. And that's exactly what I want here. But there are other things you can do with frame. Frame is one I want you to go in the documentation and look at. For example, you can specify the minimum width you want, or the maximum width and height. So there's other things you can do in frame besides just specifically picking one. Now, the reason I say it's easily abused is that look how we've been programming. We never pick the exact sizes of things. We just put them in V stacks and H stacks, and they just lay themselves out, aspect V grids and all that. The only time we ever picked a size was when we picked the size here that fit this space. And even then, we used a geometry reader to see, well, how much space do I have? And then I divided it up. So even then, I was kind of reacting to how much space I was given. Here, I'm picking a specific height. And let's go ahead and make a little constant for that. Private let deck width, which is a CG float. Let's say 50 or something like that. I'm picking a specific height. You don't want to do this very often. Now, why am I doing it here? Because I actually want this thing to be this little size, no matter what size my card is. I want the deck, I'm going to put it right here. I have a nice little open space to put it right here. Put it here, and I want it to fit in this space kind of nicely, even if my cards are huge, because I only have, 4 pairs or something like that, or even if they're tiny, I want it to be here. If you find yourself doing this, frame, width, and height, really think, is that really what I want here? And I'm doing it in this demo mostly to show you it can be done, but you will have entire apps where you never do that. Never pick a specific height and width. Right now, I deal the cards out when my container appears. I'm going to change that so that I deal them out when I tap on the deck. So I'm going to change this to on tap gesture. Do the exact same thing, but I'm going to do it when I tap on the deck instead of when my container appears. Let's put our deck in there. I told you I wanted to put it between the score and the shuffle. Here's that H stack of the score and the shuffle. Put my deck right here, put a spacer. So here we go, run. All right, there it is. Little deck that looks about 50 wide. It's there, it's black because I didn't set it foreground color to orange. But tap on it, woo, it made all my cards come in. Now, the cards didn't come from here. And what happened to the deck? Can anyone tell me why that deck disappeared? Exactly. because there are no more undealt cards. If you look down here in our deck, it has a Z stack of the undealt cards. And as I added all the cards right here to dealt, the undealt cards disappeared. They were gone. And so these views in the deck, what happened to them? They transitioned out, and they transitioned with opacity because that's the default transition. So watch again. The deck, when I click on it, it's going to disappear with opacity. See? Right, that's good. Now, I can control this card view's transition as well. In fact, let's go ahead and put the same transition on those card views as is on this one. In other words, random transition. Now, these cards, the undealt ones, are transitioning out. The cards up here are transitioning in, but they're still transitioning. Both of them are still transitioning. So if I use that crazy all over the place transition, it'll work for the cards too. Watch this. Whoop, they went off random place, 1,000 plus minus 1,000 out there too. Now, this is clearly not what we want. However, we want these card views to match the geometry of those so that the cards fly from the deck up to where they're supposed to be. And that's this thing we had in the slides called matched geometry effect. We want the geometry, which means both the size and the position, to match between those. And as one is leaving and the other one's coming out, their geometries will get automatically animated to match each other. So let's do that. Instead of having this crazy transition here, let's use a matched geometry effect. And matched geometry effect wants an ID. That's to identify this view so it knows which other view to match it with. Well, this card view right here is showing that card. So card.id is an extremely good way to identify this card view. It's the card view for that card. And we need this namespace. And this namespace is not important for us because we only have this one thing going on, but it's important for you in your assignment 4, because in assignment 4, I'm going to ask you to do dealing the cards out in your set game and also discarding them to a discard pile. So you're going to have both a deck and a discard pile. So you're going to need 2 different namespaces so that the card IDs, it knows whether you're talking about the view that's coming from the deck or the view that's going to the discard pile. So how do I do a namespace? It's really easy. You just make one up right here. I'm going to say @namespace, private var. We'll call this my dealing namespace. And then I just put right here, dealing namespace. Now, as I said in the slides, you don't have to say dealing namespace :namespace. The @namespace, which is kind of like @state, but it's a different one, @namespace. It knows that it's always creating namespaces there. That's what it does, so you don't need to put that on there. Well, here's one match geometry effect. I always need the matching one. So let's go up here to this card view, get rid of its crazy transition, and instead put its match geometry effect. And it has the same card ID there and in the same namespace. If you don't put in the same namespace, obviously they're not going to match. Let's try it. All right, here we go. Ooh, well, yeah, kinda. A little weird because they started out black and then they kind of faded to be orange. Did you see that? Let's see it again. They did match their geometries, but they also are still doing this fading business. Well, this guy has transition opacity, so he's fading out. These guys have transition opacity, they're fading in. That's not really what I want. And the lesson here is dot transition is still in effect. Even if you do match geometry effect, that is going to match the geometry, but the transitions are still there. Now, that's not what we want here. We actually want, when we click on this, it to immediately just start showing me my orange cards. As soon as these disappear, we want them gone. We want these ones to start to immediately appear. So does anyone remember what the transition you use is if you don't want anything to happen? No opacity or scaling or anything? Anyone remember? Identity, yes. So what happens if I go here and say, dot transition, the identity transition? And we'll do the same thing for our deck. Now it should work, right? Because they're not going to do any fading or any other kind of transition. Let's see what happens. Here's our deck, and tap. Whoa! We lost our entire match geometry effect. They just jumped. So the lesson here is transition identity means no transition at all. Not match geometry, nothing. Now we're in trouble. How do we stop this? Well, there's a really important little trick to know, which is that we can create an asymmetric transition that is identity for insertion and identity for removal, which you would think would be exactly the same thing as transition identity, right? Identity on both sides, inserting the view and removing the view. But this does not override the match geometry. So if you want to do match geometry and you don't want any other transition, you have to use one of these asymmetric insertion removals. And I need to do that with both of my things here. So let's go back up and do this one and run and tap. All right, that's what I wanted. I tapped on this, immediately turned to the orange cards, and they started flying up here. That's exactly what I wanted. I don't want this deck to start out black, though. I want it to start out orange. I'm going to go up here to my deck and set its foreground color to my view model's color. Just like I do for my cards, I'm going to do it for my deck as well. Probably would make it look the same by doing that or something. We're almost here with the dealing of the cards, but there's a little more to do. Let's try this though. Yes. The only thing about this is, I don't hear any of you complaining, but I've never seen anyone in Vegas deal like that. Well, let's deal. Throws all the cards out. That'd be awesome dealing though, wouldn't it? If you could just perfectly throw them out there, you'd be a great dealer in Vegas. You'd be like a sideshow. Dealers deal by dealing one card at a time, right? Flip them out there. So we want our deal to be exactly the same way. Now, how are we going to do that? Because we are throwing all of these cards out there at once. When we click on the deck here, we got this for loop. We're dealing all the cards all at once. Well, that's okay. We can keep doing that. Remember that animation doesn't show us what happens instantly. It shows it over time. So all we really need to do is delay the animations of the subsequent cards by a little bit more each time so that we're still throwing all the cards out there, but we're seeing it more and more delayed with every card. That's really easy to do. I'm just going to go here and put the card for loop around the outside here. And I'm going to create a delay, which is a time interval. We'll start out with 0, no delay. And then when we do this ease in, ease out, I'm going to say dot delay this by delay. Starts out 0. And then each time through the loop, I'm going to say delay plus equals, let's try a quarter of a second. Every card, we're going to deal the next one a quarter of a second later. And it's taking 2 seconds to deal each card. So this is going to be kind of a slow deal. Now, when I do this, I get this really annoying error. Result of call to with animation is unused. Why is it saying that? That is just ridiculous. I didn't do anything, and now it's saying this. What does it mean here? Well, with animation, for good or for bad, has a feature, which is that it returns whatever this returns. Whatever your closure returns in here, the with animation will return it too. And why is it doing that? It's because this has an implicit return. Right? We know that if you have a closure with one line, that it's got an implicit return, and insert, which inserts something into a set, insert actually returns something. I don't remember exactly what it returns. It returns actually a tuple, I think, of, I don't even remember, something that I don't care about that it's returning. And this return is just implicit because this is a one-liner closure. So how do we get rid of this? Underbar equals, which essentially says, give me what that insert gave and then just put it nowhere. Put it in the bit bucket, right? Underbar means nothingness. This is a way to get rid of that warning. Another way to do it would have been to put this in a function that doesn't return anything. That would have been another way, but this is kind of a nice, simple way to do it there. All right, let's see if that works. Whew, yeah, and It's a little kind of slow, but it's definitely doing what we want, right? It's delaying each card animation. Let's try and clean this up a little bit to make it work a little better. One thing is we don't need to take 2 seconds to animate the card. I think 1 second might be enough. And this 0.25, maybe 0.15 would be enough. By the way, these want to be constants, and I'm going to go ahead and make them constants, put them down here, private let deal interval, which is a time interval, 0.15. That's this thing right here, deal interval. And I'm even going to have this whole thing right here be a constant. I'm going to call this my deal animation. Put this down here, private let deal animation. It's an animation, of course, equals that thing. And these are all constants. Put them up with my other constants at the top. And you can already see it's about time to start putting this in a struct, constant struct. I'm really getting to the point where I have so many constants that you really would want. And you know, these ones would want to be in an animation substruct, probably, all kinds of nice stuff, but we're not going to do that, but you get the idea. All right, so let's try this, these numbers. That's pretty good. That's pretty good. I think it could go even faster, probably, you know, 0.5 seconds or whatever. So you can play with that. And maybe we want to play with the ease in, ease out. Like, probably for sure want ease in, but maybe we don't want the ease out. Or maybe we want the spring, right? We're throwing them out there, and when they land with just a little bit of dampening, they would land. You see, you know, remember the interactive spring? Maybe that's what we want. So we would play with that and get it to be what we wanted. I'm going to clean up again. I got a little cleanup to do, which is this whole thing. This is getting to be more than 12. Let's just take all of our deal the cards and turn that into its own little deal function. Don't need the comment anymore. We know that we are dealing. That's the name of the function even. That is it. Not only is that it for animation, that's it for Memrise in class. It's not it for Memrise for you all, though, because assignment number 6 is going to be back to Memrise. One thing I'm going to be showing you in the next 2 weeks is how to build apps that have editors and more than one page, right? Our app has this one view. That's it. You can't navigate to anywhere else. We're going to learn all that in the next couple of weeks. And so you're going to come back to Memrise, and you're going to have your themes be something you can edit and add new themes and choose them and all that. So you're going to add a whole UI for managing and editing your theme. So that's going to be your assignment 6. Okay, your assignment 4 is to animate this. Your assignment 5, just to preview that for you, is going to be about multi-touch, how to deal with taps. You know how to do taps with on-tap gesture, but you want to be able to do drags and pinches. So that's what your assignment 5 is going to be about. Not in Memrise, though. That will not be in Memrise. It's going to be in a different app I'll be showing you in the next couple of weeks. I think we accomplished everything we wanted to Memrise, and I don't see any of these that are more than 12, right? No, none of these are more than 12, so that looks good. And then in our card view, nope, none of these. Flying number, oh, that one's close. Flying numbers is getting close, but it's probably okay here. Cardify, looks good. Probably the one that's longest is right here, the logic, the true logic of our playing our entire game. And it really started getting long once we added all this scoring. Look, all this is all these lines of code are all having to do with the scoring. Maybe we would want to put that off in another function, you know, calculate score based on matching cards or something like that. But we've done a pretty good job of keeping everything simple, and I really want you to endeavor to do that for the entirety of your Swift UI programming career, not just in this class.